I hope you are well. In this video, we want to solve problem number 8 of Stanford Math Tournament. It is for 2019. The problem says the equation this has distinct roots R1 to R6. Evaluate these terms. Okay, because I want that this video be suitable for basic level student and also professional level math solvers, so I explain the first what Vieta's formula, in second part identities, third part this. So you can use timestamps in the description, time codes, and from what time to what time I explain Vieta's formula also for identities that you need and for solving the problem. So if you know, for example, Vieta's formula and you are good with identities, you can go straight forward in part 3, solve the problem. But if you don't know these things, it's better to see the video completely. Okay, first part, Vieta's formula. So let's work on this. It is what? Suppose, for example, at first let's start with quadratic equation. For example, x squared plus bx plus c equal to 0. Without loss of generality, we can consider a is 0 because we divide both sides by a. For example, if you have 4x squared plus 3x minus 5 equal to 0, you can divide by 4 and say, okay, x squared plus 3 over 4x minus 5 over 4 equal to 0. We say something like this without loss of generality. We can consider the leading coefficient. We call this one leading coefficient. 1. So let's consider this one. Suppose the roots are, for example, alpha 1 and alpha 2. So we can say it is equal to x minus alpha 1 and x minus alpha 2. Now, here if I write this one, it will be x squared minus x alpha 2 minus x alpha 1 plus alpha 1 alpha 2. And it will be x squared plus x minus alpha 1 minus alpha 2 plus alpha 1 alpha 2. And if we consider this equation and this, they are equal, so the coefficients are equal. So we conclude what? B, the coefficient of x, b equal to negative alpha 1 negative alpha 2, and c, the constant, equal here, the constant equal alpha 1 times alpha 2. Now, we can conclude what? We can say, okay, so sum of the roots alpha plus alpha 2 equal to negative b, and alpha 1 alpha 2 equal to what? C. If you have a here, because we've divided by the coefficient, you can say negative b over a, c over a. So it is for what? It is for example, the quadratic function. Also, if we have cubic function, for example, x squared plus bx squared plus cx plus d equals 0. Similarly, we can say it is x minus alpha 1, x minus alpha 2, x minus alpha 3. Let me write rest with blue. Okay, so coefficient of x3 will be okay. In both sides 1. Coefficient of x squared left side b. Right side, you should select 2x and one other part, negative alpha 3. Similarly, you can say, for example, if you select these two x's and then negative alpha 1, it will be negative alpha 1, negative alpha 2, negative alpha 3. If you consider x, coefficient of x, left side will be c, right side will be what? If you want to calculate that, okay, so coefficient of x, you select, for example, x here, and then negative alpha 1, negative alpha 2, negative, negative, positive, it will be alpha 1, alpha 2, similarly, plus alpha 1, alpha 3, plus alpha 2, alpha 3, and the constant is what? Left side d, right side negative alpha 1, alpha 2, you shouldn't select x, negative alpha 1, alpha 2, alpha 3. So here for degree 3, we found that we want to generalize this. So if I want to generalize, I say, okay, xn minus an minus 1, xn minus 1, plus an minus 2, xn minus 2, and plus to a1x plus a0, and it will be what? It has n roots, we know this, x minus alpha 1, x minus alpha 2, because the degree is n. Roots can be also complex numbers. From the fundamental theorem, you can say, okay, n roots, they can be complex or real roots. So here, if you consider coefficient of xn, it will be okay, 1, 1 here. If you consider coefficient of xn minus 1, it will be what? Left side will be an minus 1. Let me write with blue this part. Okay, and an minus 1 right side. If you xn minus 1, you select from n minus 1. Here, how many parentheses do we have? N. From n minus 1, you select xn minus 1, and for example, you select x from all of them, and negative alpha 1. Similarly, you can next time you select x here, this x here, this x, and alpha 2 here. Let me show this. For example, here you select x here, this one, and x here. So it will be negative alpha 2, and similarly you write negative alpha n. And it is coefficient of that. So for the next one, an minus 2, you should consider coefficient of xn minus 2. You should select from n minus 2 x, and from other two, for example, alpha I, alpha j. So it will be alpha 1, negative alpha 1, negative alpha 2 will be alpha 1, alpha 2 plus alpha 1, alpha 3. You write all the possible cases, 2 alpha n minus 1 alpha n. Similarly, an minus 3 is degree of coefficient of xn minus 3, it will be alpha 1. For the next time, because we select 3 alpha 1, alpha 2 here, we select 1 alpha 1 here, we select 2 alpha 1. For the next one, it will be negative alpha 1, alpha 2, alpha 3, because we select negative, 3 negatives, and it will be that. Minus alpha 1, for example, alpha 2, alpha 4, and to negative alpha n minus 2, alpha n minus 1, alpha n, and we write the last term is a0 here, and right side, you should select alpha I. It will be negative 1 to the power of n, alpha 1, alpha 2, to alpha n. Now, here, what can we conclude? We can write it in this form. You say alpha 1 plus alpha 2, let me write here, alpha 2 to alpha n, sum of degrees, is negative an minus 1, because if you multiply this by negative 1, this term, it will be what? It will be negative an minus 1. Here, now we want to consider this one. Alpha 1, alpha 2 plus so on, so on. It will be an minus 2. I've written this. And third one, alpha 1, alpha 2, alpha 3. Product of each, sum of product of 3 terms, 3 roots. It will be negative an minus 3. And the last one, you say, okay, alpha 1, alpha 2 to alpha n. It will be what? You multiply this by negative 1, power of n, a0. It is what we call these things Vieta's formula. Okay, so we want to use this part. You can also memorize it, or you can write down on paper. We want to use this in next parts. Okay, in this part, I want to tell the properties that we need, the identities that we need. So the first one here we need, if you consider R1 plus R2 plus R3 plus R4 plus R5 plus R6 squared, it will be what? Here, it will be this times this. You can write it twice, and then you multiply R1 to R1 to all of them. Then you have R1 squared, and also R2 to R2. R2 squared, you have these forms to R6 squared. And then also maybe the indices are not equal. For example, you multiply R1 by R2. Also, if you multiply R1 by R2, you can also multiply R2 by R1. So each of them, for example, like R1, R2, you have twice. R1, R3, last one, R5, R6, because you have R5, R6, and R6, R5. So R5, R6. So the first identity was this. Now let's consider the second one. If we have R1 plus R2 plus R3 plus R4 plus R5 plus R6 cubed. Okay, we can write it 3 times because it is to the power of 3. So if I want to calculate this, I say what? Let's find the terms that we have. Maybe I select 3 equal terms. So r1 cubed, r2 cubed to r6 cubed. Let me write this. r1 cubed plus r2 cubed plus to r6 cubed. Or maybe I select 2 from one, for example, variable r1, r1, r2. So these type of things, it will be r1 squared, r2 to last term, for example, r6 squared, r5. So how many do we have from each of them? So you select r1, r1, r2. We want to see how many r1 squared, r2 do we have. R2, you can select R2 here or R2 here, R2 here. So for R2, you have 3 choices. And if you select, for example, R2 from here, R1 and R1 should be uniquely selected from these 2 parentheses. So we can say what? We can say this one, R2 can be here, 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 and R1 from other parts, it will be 3 times that. Now, what's the other thing that is left? Okay, pause the video and try to find it by yourself. This one, let me write it again, R1. Okay, so yes, 3 different things, R1, R2, R3. So we have these things, R1, R2, R3 to all other terms. For example, the last one, if you sort, it can be R4, R5, R6, and it will be what? So for R1, you have 3 choices. 3 choices for R1. Then, for example, you select R1 from this part. Now you want to select R2. You have 2 choices are left. So you select, for example, R2 from here. And for R3, 1 choice. So it will be 6. So here it will be 6. So we've proved and we found identity 2. Now we want to find last identity that we need to use that in the problem. R1 plus R2, let me write all of that. R1 plus R2 plus R3 plus R4 plus R5 plus R6 times R1 squared plus R2 squared plus R3 squared plus R4 squared plus R5 squared plus R6 squared. Now I want to calculate this. So let's see what terms we have. If you select same terms, for example, R1, R1 squared, it will be what? R1 cubed. Similarly, you can use for R2 cubed to last one, R6 cubed. Okay, now let's select different things. For example, R1 times R2 squared. So it will be what? You say, okay, 1 R1, 1 R2 squared. Okay, so it will be R1, R2 squared plus R1, R3 squared to the last one, R6 times R5 squared. So here we've considered all the cases and we've written all the things that we had here. Okay, now we are ready to solve the problem. Okay, the problem says we have this equation has distinct roots, this. So at first you should multiply. For example, one way you can multiply first the last one, this one to this one, this one to this one, and then you should simplify to reach. For example, you can say first, as I said, first, last one, you multiply this. There are many ways you can multiply and simplify. Then you will reach this equation. So it is, I take all things to left hand side, so I will reach this now on. So look, for these types of problem, we should work a little on assumption, a little on sentence. Let's see the sentence, and the problem wants what? The problem wants this. It will be what? Sigma from I1 to I6. Now if you multiply, it will be what? The first and second one, if you multiply, it will be Ri squared minus R1 minus 2Ri, it will be minus 3Ri minus 1 minus 2, it will be plus 2Ri minus 4. And if we multiply it again, it will be what? Sigma from I1 to 6 Ri. Let's multiply Ri to all of them. It will be Ri cubed minus 3i squared plus 2Ri, and then let's multiply negative 4 to all of them. It will be what? Negative 4Ri squared plus 12Ri minus 8. And if we simplify, it will be what? Let's check. Ri cubed, we have only one Ri cubed. Ri squared, we have this one, negative 4, negative 3, negative 7, Ri squared. And for Ri, it will be 2 plus 12 plus 14 Ri minus 8. Okay, now if I want to write, I can say, okay, if I consider only first parts and take it outside sigma, it will be R1 squared, write it like this. R2, R1 cubed, R2 to the 3 to R6 cubed minus 7 times R1 squared plus R2 squared plus R6 squared plus 14 times R1 plus this part. This part we've written, this part. R1 plus R2 to R6. And this one, for each of them, we have negative 8. Sigma from I1 to I6. So 6 times negative 8 will be what? Will be negative 6 times 8, 48. Okay, so now I want to define something. I want to calculate this. I say what? So this one, I name it, let me write with black. S1, I call this one, the degree is 1. Some of the things, degree is 2, S2, S3. If I find S1, S2, S3, then the problem will be solved. So here, if you pay attention to this equation, S1, sum of the roots will be what? From Vieta's formula in part 1, I've explained it is negative this coefficient. You can see part 1 if you don't know Vieta's formula. It will be negative 27, which will be 28. And now I want to find S2. S2 is what? You can say R1 squared. You can say, okay, it is R1 plus R2 plus R6 in part 2 in identities. I've explained completely. You can see that. Minus 2R1 R2 to all other things. 2R1 R2 to R5 R6. So here, again, from Vieta's formula, let me correct this too. From Vieta's formula, we can say it is what? R1, R2, you should focus on this part. It is exactly plus 285. R1 plus to R6 is what? Is, sorry, here. Negative 27 is plus 27. So you replace this 27 squared. So if I want to calculate this, I multiply this one, 27 is 3. It will be 3 to the power of 6 minus 2 times this. 2 times 5, 10. We have 1, 2 times 8, 16, plus 1, 17. We have 1, 2, 2, 4, plus 1, 5. 3 to the 6, it will be 7 to 9, minus 5, 70. 9 minus 0, 9. 12 minus 7, 5. 6 minus 1, 5, 1. So we found S2 is what? S1 is what? Now, the only thing that is left, S3 we should find. So S3, again, we want to use the identity I told you in part 2. You can use timestamps to go to that part. So I want to find S3. So at first, let me copy the identities I said in part 2. Okay, from part 2, we have these two equations. So from first one, we can say what? R1 plus to R6 cubed. It is S1, we said. S1 cubed equal to R cubed to, so this one is S1 cubed, I've written here. This one is what? Is S3 plus. I call this part A, so it will be plus 3A plus 6 times this. With Vieta's formula, I can say R1, R2, R3 will be what? Will be negative of this sign. From in part 1, I've explained completely. Negative 1486. It will be positive 1486. So it will be 6 times 1486. And now let's calculate second part, second identity. It will be what? It will be S1, S2 equal S3 plus this part will be what? Again, A. This A are equal. Plus A. Now, S1 was what? From previous part, we said S1 is, we've calculated that. So S1 is 27, S2 is 159. 27 S2 is 159. So if we replace 27 cubed from first one, let's write them again. 27 cubed equal to S3 plus 3A plus 6, 6, 36, 3, 6, 8, 48 plus 3, 51, 5, 6 times 4, 24 plus 5, 29. We have 2, 6 times 1 plus 2, 8. Now here, the second equation, S1, S2 will be 27 times 159 equal to S3 plus A. Okay, I want to find S3, so I multiply this one by 3. 3 times 27, 81 times 159 equal to 3S3 plus 3A. Now, if I subtract, it will be what? 27 cubed minus 81 times 159 equal to, we have S3 here, 3S3, it will be negative 2S3, and 3A will be cancelled when we subtract, plus 8916. Okay, here it's just calculation. If you calculate one equation, one variable, you will reach S3 equal to 1056. Now, we are ready to find the answer. Here, we've simplified the thing that problem wants, the term, and we've reached this part. Okay, so now let's work on this. We know S1, S2, S3, and we can calculate now. So let me call this part F. Now we want to find F. It will be what? S3 minus 7S2 plus 14S1 minus 48. And if you replace, it will be 1056 minus 7S2. S2 is what? 159. We've calculated that plus 14S1. S1 is what? 27 minus 48. So you need only multiply these two terms and these two terms. And then if you calculate and multiply and simplify, you will reach 273. So we found the answer of this problem. If you've learned something new, please don't forget to subscribe, like the video, and if you had any questions, turn on notifications for having next videos. And if you had any question, comment, or also feel free to send message to my WhatsApp number in the description and comments. There are some ideas. If you learn them, then with that ideas, that theorems, you can solve any problem, Harvard, MIT, Stanford, or so you can use the card on top of my video. There are lots of problems, lots of Stanford, MIT, Harvard problems, and by solving them, you can improve your problem solving. Thanks for watching my videos and for your support. Bye.